Okay, so welcome to day 4 of the Fabrication Bootcamp. Today we're starting off with materials. Okay, so the first material is aluminum. It's pretty lightweight and relatively easy to machine. It's also relatively strong. So there are 3 kinds that we use. There's 6061, which is most often used. 5052, which is easier to bend and move around. And then there's 7075, it's a lot harder and stronger. We use it in Thunderhex, but that also makes it difficult to machine. And aluminum is a lot lighter than steel, but it's also a lot weaker than steel. So steel is heavy, strong, and hard to machine, which is why we use it less than aluminum. Next is PVC. It stands for polyvinyl chloride. You might recognize it from plumbing tube. And so PVC has this thing called schedule, and you use it to determine the thickness. So there's schedule 40 and 80, which are most commonly used. I think there's a 120, but it's not really used that often. And then there's Delrin and acetyl rosin. So these are cheaper substitutes for Teflon, and you might know Teflon from nonstick pans. Teflon's really smooth and slippery, but the problem with these is that they're prone to cracking. And then we use Delrin and acetyl rosin on electrical components, gears that don't take up much force, bearings, and spacers. So next we're going to talk about how you can read CAD. So when you're reading CAD, you should check for dimensions of the cuts and holes that you're going to be making. Look for tolerances. So what tolerance is it's how wrong you can be when you're making things. Because when you're making like cuts and holes, you can't be exactly right. So a tolerance is how wrong you can be for it to still work okay. And then you should also identify the material that you're going to be using and then figure out how you should assemble it. So if you see on the 2 bottom left images, there is a small 2 inches there and then a small 0.25 inches. So you can see that this piece is a 2 by 2 square, and then that you're going to be drilling a 1/4 inch hole in the middle.
All right, now we'll be doing powder coating. Just do next slide. All right, so powder coating is a finishing process where we basically just add color to our metallic parts by spraying a powder sort of material onto the surface, and they'll later melt and harden into an even coating. Our team likes to use blue and black because they're our team colors. Because do play the video. Alright, so the powder coating process is very simple. The first thing we want to do is clean the metal part thoroughly, and we try to avoid direct contact with the metal while doing this because the powder will not stick properly to the metal if there are dust particles or even fingerprint smudges. We then use a powder coating gun, which you saw in the last slide in the video, connected to a wire to apply the powder to the part. And what the wire does is it electrostatically charges the powder so it'll stick to the metal part. We then place the part in the oven to cure it, and it's important that we don't touch the metal during this part or the powder will get smudged. And that's it. It's pretty simple. It comes out the oven and we're ready to use it.
So powder coating seems pretty complicated compared to just normal paint. Does anyone know why we would choose powder coating? Okay, so powder coating is a lot more durable than normal paint. And since our robot's going to be bumping around and hitting a lot of stuff in competitions, we want to choose powder coating because it's more durable, and since it's going to be scratched a lot, this is the better option.
So when you're powder coating, there are a couple of things to keep in mind. The first is when you're cleaning the metal part with the acetone, you don't want to spill it on your skin or clothing because it will irritate your skin. I know this from personal experience. Wear a mask, like in the video a couple of slides ago. The person that was powder coating wore a mask, and that's because you don't want to inhale the powder coating powder because it can be very bad for you. Hold the powder coating gun away from you because once it stains your clothing, it is hard to get out. Don't touch the exposed wire that's connected to the gun when connecting it to the powder coating gun because it can shock you. Use pliers when removing the part you are powder coating, and be careful when dealing with the oven because it's hot.
So, starting off our review, I'm going to start with just general safety. So, when in the wood shop or the pits during competitions, you need to wear safety glasses at all times. If you have prescription glasses, you can either wear bigger glasses over them or wear side or face shields. Make sure to wear shoes that completely cover your feet to protect your toes and soften the impact of any objects that could fall on your feet. Tie up long hair to make sure it doesn't get caught in any machines. Always be aware of everything happening around you. When you're in the wood shop, there's going to be people using machines, obviously, so make sure you're careful around them. If you need to use a machine and don't know how to use it, always ask a mentor or a lead because it's better to learn how to use it than just attempting to use it on your own. Don't mess around in the wood shop or the pits because we want to represent 2 to 6 in a good way during competitions. And don't be in the pit area during competitions if you're not scheduled to be there because then we'll just have a crowd of people and it'll just like congest the area. When cleaning or organizing the wood shop, return all tools to their proper places and use a box or a bag for loose parts or unfinished projects so that they won't get mixed in with everything else. And please use tools the way that they're intended to be used. For example, use a wrench as a wrench and not as a hammer. And finally, listen to leads and mentors at all times, but don't be afraid to ask any questions. Next slide.
Okay, so for the tools review, when we measure, it's important to remember the rule: measure it twice and cut it once, because you always want to make sure that you're not accidentally cutting too much off, because you can always like make it shorter, but you can't exactly reattach a piece. We use several different tools to measure our materials, or stock as we call it. One of the tools is a tape measure, a common household item you've probably already seen. When we measure things using a tape measure, we always want to burn an inch. This means that instead of lining up to the end of the tape measure with the material, you instead line it up using the 1-inch mark on the tape measure. This helps to increase the precision of the measurement. Another measuring tool we use is a square. The square is used for creating perpendicular lines on pieces. There's a picture of the square on the right there. Oh, it's not there anymore, but and the last measuring tool is the caliper. This is the most accurate measuring tool there is that we use in the wood shop. If you look at the picture, oh nope, the pictures are gone. I don't know why, Ananya.
I don't know, the pictures aren't there, but just keep going.
Yeah. But yeah, like if you know what a caliper looks like, you can see that it has 2 jaws. So you line up one jaw or the end jaw, and then with the end of the piece, and then you adjust it and line it up with the other jaw and with the other end. So the caliper then measures the distance between the jaws and like displays the measurement. It's very important that you zero the caliper out after every use so that we can get accurate measurements. Now for marking tools. Now, the name is pretty self-explanatory, so marking tools are generally used to mark pieces, especially when you're cutting or measuring. The first marking tool we'll go over is the scribe. The scribe is a sharp-pointed tool, and it's also the most accurate tool you want to use. And it's like anything that the next The next thing that you would use is a marker, which is like a thin Sharpie or anything like that. And you only ever want to mark pieces with a marker when it's all right to have a rough approximation. Basically, you don't have to be super precise because the markers tend to be thicker and sometimes the scribe give us less accurate markings. Next is the center punch. So the center punch is a spring action punching tool that makes the indentation into stock when we use the center punch to make pieces when we're drilling something. So for example, let's say you're drilling into a piece of metal. You would first want to use the center punch to make a small indentation into the metal in order to guide your drill and then prevent it from drifting or walking. It's important that you use the center punch in the right spot especially. Okay, so for screwdrivers, it's pretty straightforward, but you basically use them to tighten or loosen screws. One thing that you should keep in mind when using screwdrivers, though, is to make sure that you select the right size screwdriver for the screw you're working with, just to avoid stripping, which is also when like the slots in the head of the screw have worn out, making it harder for the screwdriver to grip the screw and turn it. Wrenches are used to tighten nuts, and if you don't know what a nut is, it's a small hollow circular cylinder and it fits over the end of a bolt. Ratchets and sockets are specific types of wrenches. With ratchets, you don't need to take it off the nut to continue tightening or loosening, while on the other hand, with sockets, you may need to take it off the nut depending on the situation. When using a socket attached to an impact, you don't have to take it off, but you do need to otherwise. You've probably seen saws before that they're just used to cut pieces of wood. Or yeah, and when using two types of saws, we have two different types. So there's the hacksaw and the reciprocating saw. And the hacksaw are used manually, while the reciprocating saw are used electrically, or they're like electrically powered. Okay, next slide. For the drills and impacts, they're used to tighten and loosen fasteners, and an impact is more compact and lightweight. However, also has more torque than a drill, making it superior at directing their force downward. So they're more comfortable to use over a long period of time. It is important to make sure that you use the right size of a power tool in order to avoid stripping the screw. Another hand tool is the file. And we use multiple types of files for different jobs, and they're mostly used to smoothen edges and remove material or rough metal edges after cutting. Allen keys are smaller, L-shaped tools that can be used to tighten or loosen bolts that have the hexagonal socket. Deburring tools are used to get rid of burrs or sharp pieces that are still stuck on the stock after cutting, similar to a file that removes rough metal edges. Next slide, Christopher.
Okay, just a second. My computer's acting up. Okay, that should do it. Okay, so the next part is the electrical part. So the first tool we're going to talk about is the wire stripper. So it's used to strip down insulated wires. So you can use this for two purposes. The first thing is take off that wiring layer, take off the wire layer so you can see the pure copper wire. Or you could use it to cut down a size so you still have that insulated layer, but it's just a smaller size. And then the next tool is the crimping tool, which is used to put two metal pieces together, so one of them is deformed, and what it does is secure it in place, and we typically use this with our batteries, so it's used to attach power pole connectors to the wires. And the last thing is soldering. So soldering is the process of combining two metals using a solder, which is basically heating the metal up and then putting it together. So for this, typically you'd use metals with lower melting points for safety reasons. And with a solder, there's also a flux, and it's a cleaning agent used before and after you're soldering. So it cleans the joints and it prevents any oxidizing or reoxidizing from occurring.
Okay, so like we explained yesterday, a battery is the source of energy for the robot, and our team uses 12-volt lead-acid batteries, which need to be handled very carefully, and I'll be going over how to handle them in a minute. Um, the battery beak measures the battery's internal resistance, state of charge, and determines overall health of the battery. Internal resistance is the opposition to the current flow, and we want it to be lower rather than higher because the lower the internal resistance, the more current it can output. For competitions, internal resistance can be no lower than 6 ohms. A brownout is when the voltage of a battery drops below 9 volts, which is indicated by the power light on the Robo-Rio. A brownout is different than a blackout, and brownouts can be more dangerous than blackouts in many cases. You can, however, prevent a brownout, but by planning beforehand, monitoring battery usage, and using thicker or shorter wires to lower resistance. Obviously, try not to drop the batteries, but on the off chance that you do drop one, tell a lead or a mentor as soon as possible. Never hold a battery by its wires. Make sure to hold it by the base with both hands. If a battery leaks, again, tell a mentor first, then put on gloves, use baking soda to neutralize the acid, place the battery in a plastic container so that it doesn't leak anymore, and then remove your gloves without getting any of the acid on the gloves on your hands. Next slide.
This is John Toohey. I have a question for the group. Does anyone know why you do not hold the battery by the wire?
Yeah,
Yes.
probably because the connections between the actual wire and the points on the battery aren't as strong as, or aren't as effective as just holding the battery itself, because the battery is pretty heavy, and putting that much stress on the wires would, over time at least, cause them to break quicker.
Yeah, I think the battery is at least, I think, 12 to 15 pounds or so. It's lead
Yeah,
acid,
quite heavy.
so it's very heavy. And those connections, even though they're strong, when you pull by the wire, those will get loosened eventually. And even if you don't pull by the wire, over time they will come loose. So we always try to retighten them periodically. So you never pull them by the wire, because many times we've seen it and it'll just break right there eventually, because the wire is screwed onto the terminal very tightly. But the wire itself is just copper flexible wire, and so if you keep bending it, eventually it will break. So never do that. Yep. Okay, good.
Okay. The next part is hardware. So we covered this yesterday. The first part of the hardware is Robo-Rio, so it's considered the brain of the robot. This is where all the code inputted by the programming group is executed. So it basically tells the rest of the parts what to do and how to do it, so the robot can perform on the field. It's used for signal connections to other parts, so it can tell the other parts what to do. And one major thing you shouldn't do is cut metal over Robo-Rio, because if it gets into those small ports, it can cause the robot to malfunction, and that's because of the Robo-Rio. If it can't send the proper signals because there's metal in the ports, then the robot will obviously malfunction. The next piece of hardware is the power distribution panel. It's considered the heart of the robot because it's the central distributor of power. So it takes in the power from the battery and sends it to wherever it's needed. And what's attached to this is this snap action circuit breaker. So it takes 12 volts from the power distribution panel, and it basically limits it so that only some amount of current is sent to the smaller parts. This is because some of the smaller parts can't take the high voltage or amps, because it would cause them to break down, or it might ruin the wiring around the area, which is not a good thing. So the next part of hardware is the voltage regulator module. So this is added to the PDP, so it takes in 12 volts and makes it available for the other smaller devices, so such as radios and sensors. So it reduces the current, and it regulates and supplies voltage to Robo-Rio because it doesn't need 12 volts. The next part of hardware is the robot wireless radio. So this is used to communicate with the RoboRio via Ethernet plug. So the range indoors is 550 to 100 feet, which is 2 to 3 walls, and the range outdoors is 400 feet. And the last part is the circuit breaker. So this is like a manual on and off switch. So the red button switches it off, and the black lever turns it on.
Alright, we covered this yesterday, but just doing like a quick overview. Pneumatics is just the subsystem that controls the pressurized air to control the physical systems. So through the control of the movement of compressed air, it pushes and retracts the cylinders, which helps move mechanisms that have two set positions. So with FRC, pneumatics do have a couple of advantages. They're relatively easy to design and put together, and they're lightweight, low maintenance, and they're quite powerful because the pressurized air creates a lot of power. But on the flip side, they can take up more space, and they can require more programming. So the first part of the pneumatics subsystem is the PCM, or the pneumatics control module, and it's the key component. It communicates with the RoboRio, takes in the code, and sends directions to the solenoids, which the solenoids in turn they pass the air to the pistons and whatever pneumatic devices are in the systems, and it dictates how much air goes in and comes out and just the general airflow. The PCM also directly connects to and controls the air compressor and the pressure switch. So what the air compressor is it just basically pushes the air into the air storage tanks up to 1 gallon's worth, and creating pressure, and it is connected directly to the PCM. So the compressor can produce a significant amount of vibration when it's being used. So we use these rubber vibration isolation mounts to mount the compressor to a solid surface. And it's important that the material that the compressor is mounted to is a stiff piece, maybe like an aluminum plate, or else the vibration won't be isolated. It's also important that the compressor isn't in direct contact with anything else except the surface that it's mounted on, because it can get very hot. We don't have the picture of the compressor on the side because we just went over it yesterday, but there's a handle lever-like thing on the compressor called the relief valve, and what it does is it connects to the compressor and it limits the pressure on the compressor to 120 psi. And if you don't know what psi is, it's pounds per square inch, I think. I don't remember, but that's what we use to measure pressure. And the relief valves are manually set and will open on their own when the pressure goes over that threshold. But you can also turn them on by hand to release the pressure. So they're extremely helpful because they prevent overpressure if the pressure switch, which is next, if the pressure switch fails to turn off the compressor. So the pressure switch is used to limit the pressure on the compressor. We just talked about how if the pressure switch doesn't do its job properly, the relief valves come in. But the pressure switch will turn on around 115 psi and close at around 95, and it's used by the PCM to turn the compressor on and off with the goal of keeping a 120 psi pressure supply. The pressure switch also connects directly to a port on the PCM. So the air storage tanks do exactly what it sounds like. It receives and it holds the air, and it serves as a temporary reservoir for the pressurized air that comes from the air compressor. This just gives you a reserve of compressed air that the pneumatic cylinders can draw from. You can use more than one air tank with your robot, but each one can only withstand up to 125 psi. And also, I didn't put these on the sides, but in between the air tank and the air being supplied to the cylinders, there's a pressure regulator that we talked about yesterday, and it sets the pressure to 60 psi instead of 120. All right, please do. Next slide. So from the other side of the pressure regulator, the air is directed to control valves, and these valves are connected to the PCM and are controlled by the code that we input. So we basically get to determine when to open and close the valves. So these control valves that manage the airflow, they direct air to cylinders where the air pressure causes the cylinder shaft to move in or out So these cylinders and the valves that control them come in two types, single action and double action. There are a couple of diagrams on the slide right there, but single action cylinders have a spring that retracts the shaft when air pressure is not applied, and when the air is then applied, the shaft moves out and remains out as long as pressure is applied. And then when pressure is removed again, the spring retracts the shaft. So single action cylinders have only one air input port and are controlled by single action valves. And these single action valves have one input port, which is the air from the regulator, and one output port, which is connected to the cylinder. The valves open when power is applied and has a spring that closes the valve when power is not applied. And the pressure is only present at the cylinder when the valve is open. All right. And double action cylinders, they work a little bit different than this. They have two sets of input ports and no spring. So with double action cylinders, you apply air to one port and open the other port to move the cylinder shaft in one direction, either in or out. And then you apply air to the other port to move the shaft in the opposite direction. So the shaft stays in either the in or out position as controlled by a double action valve. And these double action valves have two output ports, one for each of the ports on the cylinder. And it has like a sliding gate kind of thing inside of it that moves one side to the other and applies air pressure to one output port or the other. So when air is not being applied to an output port, the port is vented to the atmosphere. The code that programming writes is actually what moves that sliding valve from one side to the other to change which output port the air pressure is applied to. And also there is, down there, there's also just like a general diagram, and it's just an overview of how the pneumatic subsystem works. So the air comes from the compressor, it then flows into the air tank, which serves as storage until we need to use it. And then the pressure switch, which connects to the PCM directly, it controls the compressor. And then the pressure regulator decreases the PSI from 120 to 60. And from the other side of the regulator, it powers the solenoid valves, which then move the cylinders in and out, either single acting or double acting. All right.
Alright, so each motor on the robot must have its own motor controller, which must have a connection to the robo-rio, or the brain of the robot. The two motor controllers we went over yesterday are the Talon SRX and the Victor SPX. The Talon SRX supports CAN and other advanced communication protocols and takes inputs from encoders to help measure rotational position and velocity, which helps perform advanced controlling. It also provides heat dissipation, so any heat produced is dispersed away from the electrical components, improving its reliability and preventing premature failure of the motor controller. The Victor SPX is the other motor controller we discussed, and it's far cheaper than the Talon SRX, but it lacks features like data ports, motion profiling, and temperature sensors.
Okay. The next part is power wires. So within all these electrical components, to provide current, we use power wires. And among these power wires, there's a variety of gauges, and that refers to the size of the wire. So the thicker the wire, the lower the resistance, which means greater current flow through them. And black wires are known as ground wires. So the next part is CAN, which stands for Control Area Network. So it's a system that allows communication between several electronic devices on a single network. So in our case, it links our robo-rio, PCM, motor controllers, and PDP. So they can all work together in unison, and we can get whatever necessary data we need to better understand and run the system. So among this CAN, there's high CAN ports and low CAN ports. So the yellow represents the high CAN ports, and the green represents the low CAN ports. The difference between the high and low CAN ports is just the voltage difference. So one is greater and the other one's lower. And the CAN wires are typically daisy chained, which I'll talk about in the next slide. So daisy chaining, it's a wire scheming where multiple devices are put into one circuit. It's also known as a series circuit. So the major disadvantage of this is when one device is shut off, all of them shut off because there's only one path for current flow. And then the next part is Wago and CAN connectors. What you need to know about this is basically connectors, they work as ways to manage current flow. So they can redirect current flow in whatever direction is necessary to run the electronic device. And we typically daisy chain on CAN wires. The next component is the PWM, which is pulse width modulation. So it's a method that controls the average amount of energy that goes into an electronic device. So it's a very common method, very highly effective, low energy loss, and very precise. So it's commonly used in the automotive industry, but what it basically does is that it reduces the amount of power going in, and it gives us control. And you don't need to know much in depth about this, but what it basically does is it basically rapidly turns on and off the system so that the voltage going in is lowered. The next part is a ribbon. So it's typically it's a set of wires that run parallel with each other and that are combined with each other, and it's typically used to connect sensor to motor controllers. So we use ribbons for mostly data transmissions. So between sensors and motor controllers, there's a lot of data that needs to move through both of them for them to operate properly. So that's what ribbons are typically used for. And then there's the Ethernet cable, which, as mentioned earlier, it connects the radio to the robo-Rio so that we can directly communicate it from the driver's station. And the last aspect is the AWG, which basically measures the wires, the diameter of the wires. So as the gauge number increases, then the diameter decreases.
Okay, drivetrain. So there are two main types of drive.
I'm sorry, did you cut out for anyone else?
Yeah, she did.
Yeah, you cut out for me.
Okay, Nani, can you restart the slide? Alright, I think she's having technical difficulties. Or can you go ahead and do the slide?
The drivetrains one, right?
Yeah.
Yep. Okay, so there's two different kinds of drivetrains. We have the tank drivetrain and the holonomic drivetrain. And the pros of the tank drivetrain is that they increase pushing power and are easier to design, program, and drive. And one of the cons is that it's just decreased maneuverability overall, so it's just harder to move around. The holonomic drivetrains, though, one of the pros is that it's the opposite of the con of the tank, which is just increased maneuverability, so it's just easier to move. But this one is harder to design, program, drive, and there's a harder time pushing it. The tank drivetrains have 4 wheels and can use omni wheels to reduce scrubbing, and the 6 to 8 wheels and the middle wheels can be set lower than the outer wheels by 1/16 of an inch. So what is scrubbing? Scrubbing is when the sides of the wheels of the tank drivetrain drag across the floor while turning, causing friction. If you look at the drawing on the side on the slide, it shows a tank drivetrain robot turning. With the inside arrows, the corner arrows representing wheels and turning in representing the wheel and turning in that direction, while the small arrow pointing outwards shows how the wheels will drag, causing the wheel scrub. These tank drives that I just talked about can have either 4 or 6 wheels, as I had previously said. Generally, we like drop centering, but if for any reason we want to avoid it, because we can place omni wheels for the corner wheels of the drivetrain. Next slide. So there are several different types of holonomic drivetrains. One type is the Mecanum drive, a holonomic drivetrain with 4 Mecanum wheels. Each Mecanum wheel has independent motors and has angled rollers at 45 degrees, which allows the Mecanum drive to move in all directions, including diagonally, without turning. However, due to the same angled rollers, the Mecanum drivetrain can be pushed over easily. The Omni wheels have rollers on their surface, and these are the second type of wheels that we're going to talk about. And the Omni wheels are weaker than the tank wheels. They have rollers on them on their circumference, which allow them to move forward, backwards, left, and right without having to turn completely, but they cannot move diagonally like the Mecanum wheels. There are several kinds of holonomic drivetrains that use Omni wheels. One type is the Kiwi. This drivetrain uses 3 wheels positioned in an equilateral triangle, all 120 degrees apart. They are harder to push over and stronger as well as maneuverable, but they have low traction and can be easily spun and moved. Kiwi drivetrains are complex to build and hard to program, so no one actually uses these in FRC anymore, although they do show up in FTC sometimes. The 4-wheel Omni is a type of drivetrain that is similar to the Kiwi drivetrain, but instead of 3, it uses 4 wheels in a traditional tank orientation. An H drivetrain is a special kind of Omni drivetrain that uses 5 wheels instead of 4. There are still 4 Omni wheels in the traditional tank setup, but there's also an additional one in the center that is used as a strafe. H drives have low traction and are very agile and are actually easier to write code for. Okay, so moving away from Omni drivetrains, the last type of holonomic drivetrain is the swerve drivetrain, which is known as the ultimate drivetrain. So this is like the best one because it has both maneuverability and the pushing power and strength of the drivetrain itself. In the swerve drivetrain, each wheel can be operated and turns independently of each other because of specially designed gearboxes, allowing the robot to move in all directions on matter of the orientation. The one downside of a swerve is that it's one of the hardest drivetrains to design, build, and program, but the pro of it is that it comes with all that hard work comes really easy maneuverability.
So next I'm going to be talking about manipulators. The first one is an arm. You can use it to raise and lower game pieces. It's really simple to make and design. It works similar to a human arm. It's more maneuverable than an elevator, but it's also harder to use an arm to lift heavier things. And then there's a kind of arm called a 4-bar linkage, and then you use it to keep both ends of the arm at the same orientation no matter how you move the arm. Next is an elevator. You use it to raise and lower game pieces as well. Sometimes you can use multiple stages depending on how you want to move your game piece. They're more compact than arms, and they're a lot stronger. So the 2 main kinds of elevators are cascading, where all the sections of an elevator rise together, and then continuous, where each section rises separately, so that allows for more variability in how you move your game pieces. So next is a shooter. You use it to shoot game pieces into goals that are probably higher than the robot. It's good for round game pieces or anything that's a good projectile. When you have a shooter, it's good to have a flywheel so that you can maintain a constant RPM. And so there are 2 main kinds of aiming. There's a hooded and a 2-wheel. So with a hooded aiming system, you could use wheels on the bottom and have a hood to determine the trajectory of the projectile. And then the 2-wheel shooter, you determine the trajectory of a projectile with the orientation of the shooter itself. And so a turret is a rotating base. You can put a shooter on it, and it allows you to target multiple different directions easily. It allows you to orient different mechanisms in different spots while parked in the same place. And then next is an intake. An intake is just anything you use to pick up or take in game pieces into the robot. You can use wheels, grippers, or some sort of combination, and then they can be attached to an end of an arm or an elevator. Grippers are the kind of intake. It's used to clamp down an object. Just think of like a claw. It's simple and robust.
Alright, machines. So a drill press acts as a drill, but it is more precise. You work it by turning it on, having it turn really fast, and then lowering the drill bit into the piece that you're trying to drill. So when you're using a drill bit, there are a couple of things that you want to keep in mind. You need to make sure that you center punch the hole before you drill, and you also want to make sure that your piece that you're drilling is secure so that no one gets hurt. With a bandsaw, we use it to cut material similar to the hack and reciprocating saw, but with the bandsaw, the blade continuously rotates to cut the material, usually wood, plastic, or metal, so that you're not the one that's holding the saw. When using the bandsaw, it's important to make sure that the piece you're cutting is flat on the table and that you're using the right blade to cut it. And when you cut a curve with the bandsaw, you want to make sure that you make relief cuts, which are basically just removing the saw and placing it again to reduce the stress on the blade, because you're trying to cut a curve with a straight blade, which puts more pressure on the blade. Okay, next is the sander. It does similar things to the file, and it's basically rotating sandpaper so it files it for you. All you need to do is keep the piece flat on the table and then slowly push it in. The direction that you push the piece depends on what type of sander it is. The lathe is used for cutting round stock, and it rotates the stock horizontally, and it actually keeps the bit in the same place while you can move it. And so we usually use this for hex shafts and stuff like that. The lathe creates rotational symmetry, so it should be the same any way you rotate it. The last one is the mill. The mill has a different kind of bit in it, and so what it does is it cuts, so you can change the axis that you're cutting on. So there's a table that moves up, down, left, right, and front and back, and then you just lower the bit into that. Both the mill and the lathe come with a DRO, or a digital readout, that gives accurate measurements to the thousandth of an inch.
Okay, so now I think we're going to be doing a Kahoot. Kahoot, do you want to screen share that?
Just 1 second. Okay. I need to stop presenting for a second.
Just a reminder, you guys do have a test on all this information tomorrow.
Yeah, before we do the Kahoot, does anyone have any questions? Because we just went over all of the material you should know for the test tomorrow. So.
Brandon, you gotta change the settings to public. It says the Kahoot's private and I can't access it.
How do I change that? Wait, do you have the Kahoot from yesterday? We can just start with that.
Okay, yeah, we can just redo the electrical Kahoot just to drill in some things, and then Brandon, when yours, after you change the settings, we can do that.
Okay.
Let me.
Can you screen share?
Yeah, I will. Give me a sec.
Okay.
Hmm. Wait, is this the same one that we did yesterday? Hey guys, is this the same Kahoot that we did yesterday?
Guys, is it? I think it might be, yeah.
Yeah?
Yeah.
Well,
Did you
okay.
do well in yesterday's?
Well, yesterday there were 2 people, including me, so...
So you got second place or first place?
Yeah.
It's pretty good.
There were 2 people, though. Okay, I guess I placed on the leaderboard. Hey, you know what? I'll take what I can get. For sure. All right.
Yeah, who said pistons are useless?
I just
Yeah,
don't like
that's
them.
not. Well, I guess it might have just been a guess. It's all right. Ooh. Okay. I think we need an explanation for this.
Okay, so what the pressure switch does is it turns the compressor on and off. The relief valve is the one that releases the pressure when manually if the pressure switch doesn't turn it on and off. So it doesn't make sure the compressor does, it doesn't make sure that the compressor doesn't get limited. It makes sure that the compressor does get limited.
Oh.
Okay, does that make sense?
Yeah.
Yeah, alright.
Wait, which pronoun is this?
Thank you. Thank you. Guys, when do I get my medal?
You get a high five from us in person.
Hey. All right. That's
Yeah.
worth it then. That's pretty good. I'll take that. Yeah, I'll take that.
It's not because
Alright, we have
give
two
you-
more Kahoots. Kastu, do you want to do the next one?
Yeah.
More. Okay.
Just give me a
Next one
second. I
should
gotta
be like a bit shorter.
Oh, also, guys, just to preface, before the test tomorrow, the test is worth 50 points, and you'll need a certain score on it to be able to actually work on the robot during build season. We'll tell you what the score is tomorrow right before you take the test, but just know that you do need to get a minimum score.
You are going to be able to retake it, so it's not like all or nothing.
By the way, are we going to get these PPTs? Because I know that there's a video like recording.
Yeah, I can send them out to everyone's emails. I think everyone except Pranav filled out the Google form, which I'll put the Google form in the chat, so after we play the Kahoots, can you fill that out? But I have all of your emails from that form, so I can just send all the PowerPoints to you guys after.
Okay. Yep. Thanks.
Alright, is that it? No one else? Okay, let's try.
Wait, I made this. I probably shouldn't be competing.
Yeah. You might want to drop out.
Oh well.
Yeah, the
Yeah,
first
so-
thing you want to do before like actually applying the powder is just cleaning the part thoroughly before you use the
Wait, what was
contact.
that chemical that we were supposed to use? I forgot the name of it.
Acetone. Acetone.
I see.
Yeah, so acetone's in a lot of like nail polish removers and stuff.
Uh-huh.
It's not that bad if you inhale it.
Okay, yeah, I'm not gonna
don't
inhale it
think
anyway.
that. It's
If you
fine.
told me it was good for me, I'd be a little bit worried. Wait, is the person who made it H?
Possibly.
Uh-huh. Oh. Yeah, cut it. Cut it is the right answer.
Yeah, so if you just tuck your hair in, it could come undone. That's why we prefer tying it up. That should be more secure.
Ooh. Use a caliper instead. Okay, that's the unofficial right answer there.
Yeah, so calipers are more accurate, but also calipers are a lot smaller than a tape measure would allow. So if you're just like rough cutting wood or like doing a rough cut of some metal, you don't really need to use a scribe. A marker should be fine. So a center punch
That's a
doesn't
hard
punch.
one. That's a hard one.
It doesn't actually punch a hole in the metal. It just makes a small dent in it, so that way, when you drill something, it doesn't move around. Yeah, so you would use a screwdriver with a wrench.
You can use it for that added torque, you know.
Yeah. Yeah, so a wrench you would put on the nut, and then screwdriver you would use on the bolt.
Ooh. Okay.
Yeah, so reciprocating saws are a lot faster than hacksaw, because hacksaws are powered by yourself and reciprocating saw is electrical. You would use
Oh,
a
okay.
reciprocating saw in a rough cut, or you would prefer it because you don't need to be precise or anything.
Mm.
And then the blade also moves around a lot, so it's less accurate. What you can also do is start off a cut with a hacksaw just to make the indent, and then once you've gotten far enough in, continue it with a reciprocating saw. You can use an impact like a drill, but you probably shouldn't. So again, you can use a drill like an impact to screw something in, but an impact gives you more torque, so we usually use those.
All right, good job, Ishan, again.
Thank you. I have to make a confession.
Yes.
I made this Kahoot.
It was you the whole time?
It was me the whole time. I made the Kahoot.
Whoa, I
Yeah.
never
I
expected
bet
that.
you guys didn't know that. Yeah.
Before we do the last Kahoot, Pranav, since you weren't here the first few days, can you just fill out the form that's in the chat? And then we'll play the last Kahoot, which is on drivetrains and manipulators.
So how do we get just like a bunch more rookies today?
Oh, Steve, are you doing it?
Was I supposed to wait?
Yeah, just wait like 2 minutes. It's the drivetrain and manipulators one, right?
Yeah.
Okay.
The link isn't working. It says, sorry, unable to open the file at this time.
Oh, hold on, let me retry.
Have you guys checked out any of the other boot camps?
Sorry, did you say any other group?
Yeah. Have you looked at any other boot camps?
Yeah.
But Pranav, the
the
link should
business
work
one.
now.
What did you say?
I went to the business one. Yeah. So seems like a lot of bureaucracy. I mean, I liked it, but like I didn't realize the robotics team would be like so big. Like at my old school, like I was at one of the leading positions of the club, and it wasn't that big. Like it was like decently big, and we had like a lot of tools and stuff, but there wasn't so much like layers of stuff to go through.
Yeah, 226 is huge. And then
Uh-huh.
we recently split off from Athens, but before
Yeah.
that, we had even more people.
Wait, so do you guys have like multiple robots within you, or is it just like?
We just play with one robot. We
Really?
have a test
Jesus,
robot.
you have like a school's worth of people, and you're doing one robot.
Yeah.
My
Well,
God.
most of the people are divided into the subgroups and stuff.
No,
Like,
but we have other robots for other purposes, like for some of our outreach events. We do.
Well, I know, but
Yeah.
but actually competing, you just have one?
Yeah.
yeah.
Oh, so you have like 100 people working on one robot. That's
Pranav,
great.
does the new link work?
Yeah.
Yeah, I filled it
So
out.
no wonder you guys get it done in like 6 weeks.
Well, yeah. Yeah, we have a lot of people working just to get one thing done.
So are there smaller groups as well? Or
Yeah, we used to have was it RoboFest? They worked with the Lego Mindstorm stuff.
I see. Well, but that's like FLL. That's not
Yeah.
even FTC.
Uh-huh.
Okay, cool.
All right, I'm gonna screen share the last Kahoot.
Yeah.
Actually, Steve, can you go ahead and do it? Since you already have it pulled up.
Yeah, give me a second.
So did digital media go today for business?
Yeah, they did.
Can you guys see it?
Yeah, I see the thing.
All right.
All right.
Is that it?
Yeah, go ahead and start.
Okay, yeah.
Okay.
Nice. We'll all be on the podium except for one person. It's all right. Wait, there are
So-
5 people now? I thought there were 4. Okay.
I guess Jesus came back.
All right. Oh, the return of Jesus. Wow. Who could have predicted?
His rebirth.
Mm-hmm. This is the same question, but okay. Wait, 4-wheel Omni? That's an actual... No, that's just a wheel type.
No, so a
No,
four-wheel
there's
is just like a four-wheel tank, but you use Omni wheels.
Mm.
yeah.
Yeah, and then you can go to side as well. Mhm.
Yeah.
Wait, if I beat Jesus, does that mean I'm the devil? Or like I'm the bad guy? I think that makes me the bad guy.
Did Jesus have like an enemy or something?
I don't know. Probably the devil.
The Romans,
would
I
assume.
guess.
I don't know. Oh, well, okay. Good has prevailed. There we go. Although it seems Jake is more powerful than God himself.
Jake, how does it feel to be beating Jesus?
He's got God and anime on his side. Oh my god. No one can beat him. That's entirely subjective, but okay. What? What?
Swerve is just
Bro, you
generally
can't
bad.
pull that on us. Okay. Nothing, I assume. Oh crap. He uses Omni wheels. But
Yeah.
it's drive. No.
So the Omni wheels are in the shape of a H. Yeah. So you can put any kind of wheels on anything, I guess, but a mechanism drivetrain uses mechanism wheels. Yeah, so mechanism drives can move diagonally as well as like front, back, side, side, whereas Omni wheels are just front, back, side, side.
Yeah.
Yeah, so arms are really bulky. That's why a lot of times our team chooses to do like an elevator kind of thing.
Hmm.
You can also put an arm on an elevator, which is fun.
Ooh, takeover. Okay. What is that? Oh, what?
Yeah, so that's actually a 4-bar linkage. It kind of looks like a basketball hoop kind of thing. So if you can see, there are 4 bars connecting the robot to the end. Yeah, so that keeps it in the same orientation no matter how much the arm moves.
Hold on. Could it technically be a continuous elevator though? Because you're using servos to, or whatever those are. It looks like a servo.
I'll get back to you on that.
I think you could use it as one, but well, whatever.
Okay, but it's not necessarily an elevator though, is the thing. But if you guys have had like, those basketball hoops that people have in their driveway where you can like extend it
Yeah,
and
they
change the
kind
height?
of go up and down.
Yeah, that's like, that would use a 4-bar linkage.
I see what you're saying. Okay.
So like if anyone wants to visualize it, that's just an example.
All right, great job.
Woo.